Welcome back to the channel. Today we are going to discuss this problem called Kevin and the competition memories from the recent Codeforces Global Round 28. So the question states that Kevin used to get into Rio's memories, and in Rio's memories a series of contests were held. So a series of contests was once held. Kevin remembers all participants and all the contest problems from the time, but he has forgotten the specific rounds, the distribution of problems, and the exact rankings. So there are m problems in total, with the ith problem having a difficulty of bi, and let each contest consist of exactly k problems, not less than that and not more than that as well. So the resulting in a total of floor of m by k contests. So that's obvious, and this means that you select exactly floor of m by k into k problems for the contests in any combination you want, with each problem being selected at most once, and the remaining m mod k problems are left unused. So for example, m is equal to 17 and k is equal to 3. You can make 5 contests and the 2 problems will be left unused. So there are n participants in the contest, uh, all the contests. So with Kevin being the first participant, the ith participant has a rating of AI, and during the contests each participant solves all problems with a difficulty not exceeding their rating. So meaning that the ith participant solves the jth problem if and only if a of I is greater than or equal to bj. Means what they are saying is that if that participant's skill is stronger than the difficulty of problem, he will or she will solve that problem. So in each contest, Kevin's rank is 1 plus the number of participants who solve more problems than he does. Okay, so for each k is equal to 1 to all the way up to m, Kevin wants to know the minimum sum of his ranks across all m by k contests. So in other words, for some value of k, after selecting the problems for each contest, you calculate the rank of Kevin in each contest and sum up these ranks over all m by k contests. So our goal is to minimize this value. So note that contests for different values of k are independent. It means that for different values of k, you can select the distribution of problems into contests independently. So that is some big long question. So I hope you understood it. And so yes, we will be given n and m, both are up to 3 into 10 to the power of 5. So O of n into m or O of n square kind of solution won't work. And the second line of each test case will be n integers. So the rating of each participant, you can model it as a skill of that participant. And the third line for our each test case contains m integers b1 to bm, the difficulty of each problem. So it is guaranteed that both the sum of n and sum of m over all test cases do not exceed 3 into 10 to the power of 5. Okay, so let us try to get grasp of the problem by examining the sample test case. So here I have two sample test cases which they have given. This is the clear partition. So in the first sample test case, n is equal to 4, m is equal to 4. So let us arrange this skill or the rating of the participants in the increasing order for our convenience. So 3, 4, 5, 7, and don't forget that this 4, so the rating of the first participant, this 4 is the Kevin's, you can say Kevin's skill or the rating, this 4. Okay, so 3, 4, 5, 7, and the problem ratings are 2, 5, 4, and 6. So it is obvious that for k is equal to 1, each contest will have only one problem, right? First, second, third, and fourth problem. So when contest has a first problem, so what will be the rank of the Kevin? So we can see that all the participants will solve this problem too, right? So all the participants will solve this problem too, and Kevin's rank for that contest would be 1. So for the second contest, so the Kevin and this guy which has the rating less than Kevin won't be able to solve that question. So but these two guys will solve this question. So Kevin's rank will be 3 plus, what about this 4? So Kevin will be able to solve this question and so does these guys. So Kevin's rank will be again 1. What about the 6? So this guy Kevin and the guy having a rating of 5 won't be able to solve that question. So these all three guys will get the rating of, oh okay, or the rank of 2, and this guy will get rank of 2, rank of 1. So finally this one. So when k is equal to 1, rank when k is equal to 1 is 3 plus 2 plus 2, 7. So is it correct? Yes, indeed it is. So for now, what about k is equal to 2? For k is equal to 2, so what I can see is that if I okay, so the two contests will be formed, right? Two contests will be formed for k is equal to 2. So I have a choice. So these problems having rating 2 and 4 are solvable by Kevin. Okay, he can solve. And the problems with rating 5 comma 6 he cannot, right? So what is better, that you group the two problems that he can solve, or group one problem from he can solve with the other problem that he cannot solve? So we'll see what is better for him. So So one thing I can logically notice is that if we want to increase the Kevin's rank, okay, wait, not increase the Kevin's rank, so we want to minimize it as much as possible, right? So we want to decrease the Kevin's rank, decrease Kevin's rank. So that is what we need to do. So suppose if I group 2 comma 5 and 4 comma 6, or whatever, 2 comma 6 and 4 comma 5, uh, do you agree that the Kevin's rank, okay, so Kevin's rank will always be greater than or equal to the rank of all the participants which, which have rating or problem solving skill greater than or equal to Kevin's, right? Kevin's skill or rating, you can say. Okay, let us take rating only, because in the question they have said it is rating. Okay, so this is the thing. So here in this contest, you know that Kevin's rank will be greater than or equal to 2, right? If the guy uh, if the guy who is having the rating greater than or equal to 6 will solve this problem, right? And here also it will be greater than or equal to 2, right? Because some guy will solve this problem. And if I group it in a way 2 comma 4 and 5 comma 6, okay, so in this contest he is guaranteed to get rank 1, right? He is guaranteed to get rank 1. And what about here? So his rank will be greater than or equal to 2, right? Okay, so given that some guy solves these problems in the contest, so I can see that the problems which can be solved by Kevin, if they are grouped in a single contest, then his chance of getting the minimum rank is or are increased, right? So this is one observation. Observation number one. So now what about, okay, let's calculate the answer for k is equal to 2 as well. So if we take this thing 2 comma 4 as one contest, then his Kevin's rank will be 1. And in this contest which will be having these problems, Kevin's rank will be, okay, Kevin's rank will be, so this guy will solve this problem, Kevin won't, and this guy will solve both the problems, right? So his rank will be 3, right? So it is going to be 4. Is it correct? So yes, it is indeed. So what about k is equal to 3? Okay, so these are the problems that can be solved by Kevin, and these are the problems that cannot be solved by Kevin because Kevin's rating is 4. Okay, now we have seen that it is better to group the problems that can be solved by the Kevin in one group, and we have to take one more problem from 5 or 6. Okay, so which problem to take, 5 or 6? So the guys who have the higher rating than Kevin, okay, 3, 4, 5, and 7. So rating of the participants is 3, 4, 5, 7. So if you take this thing, then this participant will solve this question, right? This will solve this, he will solve this or she will solve this question, and Kevin's rank will be increased, right? But if you take this 6, if you take this 6, then this guy won't be able to solve that question, so Kevin's rank will be minimized, right? So what I can observe is that, so I have to group the problems such that, so group 1 will have problems that can be solved by Kevin, and group 2 problems that cannot be solved by Kevin, right? Okay, so what next? Again, in this k is equal to 3 case, we have seen that it is better to arrange group 2 in the reverse order. So we will arrange the questions in the following order. So group 1 in increasing or in non-decreasing, you can say, and then group 2, first sort it and reverse it, or you can sort it. Okay, you can use r begin and r end as well, so that's the part of the code. So this will be in decreasing order. First we'll focus on creating a solution or finding a solution. So this will be in increasing order, this will be in decreasing order, and then you will brute force for k is equal to 1, k is equal to 2, k is equal to 3, and so on up to k is equal to m, right? So how can I efficiently know that for each k, uh, okay, so you can see this test case, where is it? Okay, yes, so here n is equal to 5 in second test case, m is equal to 5, and Kevin's rating is 5, and let us arrange them in the increasing order, so 0, 4, 5, 6, 8, and let us arrange the questions in our order. So less than or equal to 5, 1, 2, 3 in the increasing order, and 9 and 7 in the decreasing order. Okay, so when k is equal to 1, it is straightforward how to calculate the answer. So for k is equal to 2, so this will be the first contest and this will be the second contest. Okay, so uh, what you can see here is that, so Kevin will be able to solve this problem. Okay, here it is straightforward that his rank will be 1 because Kevin can solve all these problems, and here the one who solves the problem 9 will get higher rank than Kevin in this contest. Okay, right? But we can see that some anybody isn't there who can solve that problem, right? So here also his rank will be 1. Okay, so in this test case, in the second test case, for k is equal to 2, our answer should be 2. So is it? Yes, indeed it is. So that is basically the idea. So how, so on the basis of, or you can say how to implement it. So we will store a map. Oh, map of long long comma long long. So what this map will do is that it will store indexes or indices, you can say. So uh, what I am trying to say is that it will store indices of the uh, rating of the participants. Okay, yes, the rating of the participants. And we can use the set and its functionality called the lower bound of some element. So this returns the iterator pointing to the element which is greater than or equal to the element. Okay, it returns the iterator, right? So that is basically the thing. And we will extract the value from that iterator. It will give us the value, and we will check the index of that value and do some n minus index plus 1 thing to get the length of that interval. Okay, so the length of that, okay, wait, length of that interval who can solve problems which Kevin cannot, right? So this is basically the thing. So these are implementation details. So let us head towards the code. So yes, taking the input, I'm using one based indexing here. So Kevin's rating is a of 1, and taking the input for bi, sorting the problems based on which Kevin can solve and Kevin cannot. So sort, reversing the problems which he cannot solve, and storing the problem in this store vector. So this is to ensure one based indexing. And yes, so this is map to store the indices of the elements to get the length of the interval of the participants who can solve a particular problem which Kevin cannot, or just the general storing of the indices. So sorting the a vector and inserting all the values of from the a vector, and finally here. So for LL, k is equal to 1, k is less than or equal to m, k plus plus. So we have to start from kth index and go till less than or equal to m, and I plus is equal to k. If store of I is less than or equal to Kevin, means Kevin can solve that problem. So this variable HMM, it is just storing the rank for that contest. So HM plus plus and continue. And if Kevin cannot solve that problem, we will declare a rank. And if s dot lower bound of that element is s dot end, so here it was the case, right? So this problem cannot be solved by anyone, right? So this problem cannot be solved by anyone. Can you see here? This guy, this problem cannot be solved by anyone, so it was s dot end here. So here basically his rank will be 1, right? Again, as we have seen. So that's why HMM plus plus and continue. Otherwise n minus this thing, the index of that element plus 1, and rank plus plus for one rank extra, because they have stated here, right? Where is it? So his rank is 1 plus the participants ahead him, right? So that's why rank plus plus. And finally increasing HMM by rank, and HMM is basically just some random variable name, and answer dot pushback of HMM. So finally the calculated rank, and then outputting these elements from the answer vector. So this gets accepted, and this was nice problem. I solved it on my own and enjoyed solving this problem. Hope you did also enjoy this solving this problem and listening to the solution as well. So if you like the content, consider liking and staying subscribed to the channel, and thank you for watching the video.